Hello, this is a short video on VLSM subnetting. So I'll be solving this problem. Now first off, this is the network this is the network address we have been provided, and we have to create the subnets in the most efficient way possible. So there can be only one answer for this, and this, and for this and this. For these two, the networks can be interchanged, but this and this network has to have the same answers. So let's start. First, we have to start off with finding out the highest number of hosts needed. So highest number of hosts needed here 220 out of this tree. So 220. So how can we get 220? So first let's find the network address. So as we see, 22 bits, there are 22 bits, there are 22 network bits. So these two have 16 bits. Here we have 16 bits, so we only have to check for this one. So what is the binary of 100? So let us write here 192.10. Binary of 100 is 011000100. Then 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Nice. Now we will write the subnet mask. So for subnet mask, start here. So we already have 16 over here. Now there are 17 number 17, 18, 19, 20, 21, 22, and these are so this is the subnet mask. So we see everything stays the same after we perform the logical AND operation. So the answer will be 192.10 dot 100.0. Now we see that this portion is the network bit, and we have 10 bits we can use for subnetting. So these 10 bits can be used for hosts and subnets. So the first network, we need to have the maximum network is 220 hosts. So 2 to the power 9 minus 2, that's too large. 2 to the power 7 minus 2, that's too small. So 2 to the power 8 minus 2 gives us the result of 254. So we need at least 8 bits to so that we can have 254 hosts, and so as 2 to the power 8 minus 2 is 254. So we need 8 bits to support 254 hosts, and for that we need 8 bits, and we have 2 bits left. So with these 2 bits we can make 4 combinations. So those 4 combinations will be 0 1 1 0 0 1 0 0 0 1 1 0 0 1 0 1 0 and 011 00111. So these will be the 4 combinations with these 2 bits. So let us write the let us make the subnets. So for this it will be 192.10.100.0 slash, as we used these 2, so it will be 22 plus 2. So as we make combinations with 2 bits, so 22 plus 2 is 24. Now the first part would be 192 and .10, and the second part is 101. So this will be 192.192.10.101.0 slash 24. This will be 192.10.102.0 slash 24, and this will be 192.10.103.0 slash 24. So these are the combinations. Okay, so for 220 hosts we will assign 220 hosts here, 220 hosts. So this one is used. Now these 3 are left. So for 210 hosts we will use this 210 hosts, as 2 to the power 7 minus 2 is 2 to the power 7 minus 2 is 126. So 126 cannot hold 210 hosts, so we will assign 210 hosts here. Now we need to assign 120 hosts. So for 120 hosts we need 7 bits, as 2 to the power 7 minus 2 2 to the power 7 minus 2 is 126. So we need 7 hosts, 7 bits. So these have been used, like this has been used. We'll now work with this and 8 zeros after that. So no, this has also been used. These 2 are left, so we will now use this one. So we will require 7 bits. So these 7 bits we will require, and these network bits are already used, so we have to make combination with this one. So there will be 2 combinations where this will be this will be 8 zeros and 1 0 and 7 zeros. So this followed by this 2 is the part. Now the answer so the 102 part will be the same, and first one will be the same as the previous one, but this time as we used one more bit for subnetting, so it will be 25. And for this, as we just use the first bit, so it will be 102.128/25. Now for the we have to assign 120 hosts here. It has the maximum capacity of holding 126 hosts, so we will assign 120 hosts here. Now these serial ports require 2 hosts each, so this requires 2 hosts and this requires 2 hosts, and for 2 hosts we need 2 bits. So as 2 square minus 2 is 2, so for 2 hosts we need 2 bits. So this is the number of bits we need. So we have used this one, so we need to use these 2 bits, and this 25 bits has already been used by the network. So we have total 1 2 3 4 5 bits remaining, with which we can make 2 to the power 5, that is 32 combinations, but we don't require all the 32 combinations. This will have 32 combinations, but we only need 2. So the first combination will be same as the previous one, 102.128/25. So as we now used 5 more bits, so previous one was 25 plus 5, which equals 30. This was up until this, it was 25, and now we are using 5 combination of 5 bits, so we need to add 5. So now it's 25 plus 5 equals 30. And for the second one, the combinations, I'll show you how it will be. It will be 1 0 0 0 0 5, then 2 zeros, and 1 0 0 0 0 1 0 0. The next combination will be 1 0 0 0 0 no 1 0 0 0. So we see that only we are seeing the combinations of these 5 bits, and it will have 32 combinations, but we require only 2. So we have here, we can assign this one here, okay, and for this one we need another subnet, so it will be this one, which we will find the decimal value, which is, if we do it in calculator, 102.132 /30. So these have been used. This one I'll give it to this host, this, and so for serial connections we require 2 hosts, and this is the process you should follow for VLSM subnetting. Thank you for watching this video, and these will be unused, so you can see this is unused, not this, the 30 combinations are unused, only 2 are used here, and this is totally unused. So that's it, and these are used, the ones which have tick in them. Thank you for watching this video.